Our next session is poised to explore the realms of manufacturing excellence, delving into the advances in tools, mold making, and maintenance. Our topic for the second panel is Empowering Manufacturing Excellence, Advances in Tooling, Molding, and Maintenance. In this session, we will address critical questions that guide our quest for excellence in the industry. How can precision and sustainable tooling drive efficiency in manufacturing processes? In what ways do high speed molding and new materials enhance production capabilities? How does predictive maintenance optimization equipment minimizing downtime and maximizing efficiency help? What impact do data analytics and emerging trends have on the manufacturing landscape? And lastly, what are the future opportunities and challenges for tooling, molding, and maintenance in the evolving industrial landscape? To shed light on these crucial aspects, we have a panel of distinguished experts who will share their valuable insights. Get ready for an engaging and informative session that promises to elevate our understanding of manufacturing excellence. Ladies and gentlemen, please join me in welcoming our esteemed panelists for this session. I would request Mr. Avinash Khare, ex-Tata Motors and Consulting SME, Mr. G.V. Dasarathi, Director Lean Works Industry 4.0, and Mr. Nandakumar, Division Manager, Toyota Gosei, South India, to join us on the stage. Ladies and gentlemen, it is my distinct pleasure to introduce our esteemed speakers for this session. Mr. Avinash Khare, an electrical engineer by qualification, has a remarkable career spanning 33 years at Tata Motors, Pune. Now, Mr. Khare has continued to be a driving force in the industry, dedicating his expertise to freelance consultancy focusing on automation solutions for material logistics layout and equipment. He is the creative mind behind the design and delivery of numerous training courses. He has been actively coordinating international seminars on manufacturing technologies, contributing significantly to the global discourse on industry advancement. Mr. Khare, it is our pleasure to have you here. Our next distinguished speaker brings a wealth of expertise in the realm of Industry 4.0. Mr. G.V. Dasarathi, the Director of Lean Works. He is a mechanical engineer holding a BE Mechanical from NIT Surat and an MTech in Production Technology from IIT Kharagpur. With over 30 years of experience in CNC machining, CAD/CAM software and Industry 4.0 systems, he has been a driving force in advancing technological solutions in manufacturing. At Leanworks, Mr. Dasarathi shoulders the responsibility of product design, software testing, and customer support, playing a pivotal role in the development and deployment of cutting-edge software solutions. Welcome, Mr. Dasarathi. Our next speaker for this session, Mr. Nandakumar, Divisional Manager at Toyota Gosei, South India, is a distinguished graduate from NTTF. Mr. Nandakumar brings forth an impressive professional background spanning over 28 years. Holding the esteemed certification of a Six Sigma Black Belt, he is an active member of prominent organizations such as SAE India, SAE Globe, ASQ Professional, and QCFI Life. In his current leadership role at TGSIN, Mr. Nandakumar oversees critical aspects including product design and tooling development, mold maintenance, and plant utilities. His multifaceted expertise makes him a key player in driving excellence and innovation in the industry. Ladies and gentlemen, let's extend a warm welcome to all the three panelists. The stage is set, and it is time to delve into the heart of our session, empowering manufacturing excellence, advances in tooling, molding, and maintenance. Without further delay, let's commence this enlightening session.
So, ladies and gentlemen, welcome for this short discussion on a large topic of how to implement new technology and excellence in the domain of mold, and not just mold manufacturing, but I would say plastic tooling manufacturing as a whole. Because ultimately manufacturing and not just producing individual parts, but also assembly. So to that extent, you also have joining, you also have welding, you also have fixtures, you also have metrology. The full ecosystem is what gives you excellence eventually in the manufacturing. So we cannot really sectionalize that we will only focus on mold and nothing else. So we have to look all around and talk holistically for a plastics manufacturer what we could do to bring in excellence and to infuse new technology, which is lesser known. So here the accent is to talk more about recent developments in technology, what is not already there conventionally, because the idea is to enlighten with some things that people do not already know. Right now, with this agenda, we'll start the session. Uh, my first volley of questions is directed to the molds man, Mr. Nantha Kumar, specifically. Now, Mr. Nantha Kumar, what is your perception? Like, what is the trend of demands on performance as regards quality, as regards productivity, as regards manufacturing time for mold itself? Huh? And like, what is your say? Are we expecting too much from mold makers? What is your say?
Yeah. Good afternoon, all. Yeah, it's good question, sir. Actually, the complexity, whatever the quality, whatever now the OEMs are expecting, now generally, okay, we are from the automotive industries, where the now the lead time is getting keep on reducing. Earlier, they used to have 1 or 2 years to make a molds and all those things. Now the lead times just keep on reducing it. They're the first shot is of earlier they used to make a protopart, all those things. Now the tooling itself, now they get taking the protopart. There is no like separate protoparts making it or not. So by this, the lead time is keep compressing. It's too much. It's like a simultaneous engineering. The design will be parallelly happening. The tool making is also parallelly happening. Again, not only about that one, about the product quality, about the cycle time of the parts, that is also keep on reducing it. Again, life is also a tool. Earlier they make for 1 lakh. Since the extent life is extended, the same mold will be continue for some more years also. Maybe how to extend the life of the tool to without wear and tear, all those things. However, where the steels is plays the major role, where the P20, which P20 steel we are considering the tooling first itself, which will lead to the better quality of the product and also how we are doing better manufacturing in the manufacturing stage itself instead of how to reduce the number of changes. This is where the initial feedback from the tool maker as well as from the part suppliers needed to the OEMs. So that will reduce the number of modifications. So that will not add any corrections or anything else, which will increase the tool life and also the tolerances. The tolerances now, even the customers with a wider tolerance, finally will come to the narrow tolerances. 70% of the tolerance will be only met or 50% somewhere go there. There we will keep on working on the tolerances. By this, yeah, the tool makers expectation, what the expectation from the tool makers is the quality at the first stage of the trial itself, we want 100% of the product, because the first product itself is go for the evaluation of the vehicles. So they need changes or anything, it will impact on a product evaluation. So that's the expectations most probably, and it's also we have already trying to meet all those things. That's also over to you.
See, for common layman, when we say plastic products, the first things which come to our mind are things like buckets and toys, where neither the surface accuracy is important, nor the distortion is important, nor the properties of material are so important. But when you talk of engineering products like connector, where we expect 3 micron class accuracy from a plastic part, we expect spring action, we expect hardness comparable with metal. Now, are these changes in the expectancy from the plastic products the key driver for what we expect from the mold as well?
Yes, sir. Where some of the metal parts are now due to the efficiency of the vehicle, so many of the metal parts are changing from metal to plastic. So where some of the parts is definitely the customers expect almost to the steel condition. But however, based on that evaluations and all those things, where we can negotiate the customer, to some extent the tolerance is getting it lesser also, so loosening also. It's not about customers also keep on holding the same condition, but we can validate. Being a material maker, there the plays role of both material as well as the mold makers as well as the designers of the product, all are plays a major role. It's like that's what's called a simultaneous engineering. All party combined together do the product design and the engineering and also manufacturing. This is reduce and also meets the optimal requirement of the customer.
Now, you mentioned something about materials. Has there been any major change in the material that is going into the plastic parts? And that is what is driving the change in the approach for mold manufacturing.
No, sir. Actually, plastic it is remains same. Or the where the cycle times keep on changes, the mere metal where you have the thermal conductivity of the steel to make it better, to make the better part at a lesser cycle time. Where the steel is up, where somewhere the parts is changing from metal to plastic, there the plastic measures roles is changing, where some high engineering plastics are getting evaluated and is keep on emerging in the market. So using that one, where some of the engine parts is also changed from metal to plastics.
What you said is probably true for molds, injection molds. But let me mention one class of composite product. Now, composites are also plastic in their own right, excepting that they have CFRP or GFRP reinforcement embedded in them. But CFRP and GFRP, we have tools which look like stamping dies, and they go in presses, regular stamping presses, and they can be handled with automation almost like sheet metal. The fixtures which handle them are same as what are required for sheet metal stamping. The automation is quite similar. The presses are quite similar. Other than that, yes, they are hydraulic presses with a dwell. Okay. Now, the technology is coming close to sheet forming also in some way as far as composites are concerned. So that's a new area which I want to throw open for audience to think about. And of course, you can always ask questions. So plastics are coming closer to sheet metal. That's what would be my submission here. Now, based on the factor and the available technologies, do you think the equipment is also dictating some changes in the requirement from molds? Like molding equipment and the technology which goes behind the molding equipment, is it also an influencing factor in the way the molds are made?
Yes, sir. Obviously, whatever is, it's not only the mold will take the part, the molding equipments also plays the major role in getting the product and the precision and everything. And again, the when the injection molds is earlier, okay, we being in the company, we making it bumper at for 40 seconds. So where the machine efficiency and whatever the tonnage is happening, again, what the how the cooling is happening, again the MTC is what we use it, how it has to be happen. All those things happen. Again, also where the steel, where instead of steels we use beryllium coppers, where the cooling transformation. Again, now the technology is considered where the conformal coolings, where some of the smaller tools, as bigger molds we can't able to do it. As of the smaller molds, we can do the conformal cooling like metal 3D printing. With that metal 3D printing, we can do the better cooling and better cycle times, and everything can be done. Again, related to the manufacturing time to lead time reductions, yeah, how the six-axis machine plays the major role of reducing a secondary process like EDM, other process can be reduced. With this lead time is also getting reduced.
So
So where the
conformal
roughness
cooling,
can
you
be
are saying, sir, is for cycle time.
pardon, sir?
Conformal cooling is used mainly for cycle time improvement or for quality or both?
Cycle time, cycle
Cycle time,
both,
both.
both.
Quality
Sometimes,
as
yeah,
well as
quality
cycle time.
too. Sometimes is a generally majorly used for a uh, cycle time.
Where my
Sometime
question,
is
yes,
used
sir,
for quality too.
sir. Where my question came from was actually the requirement of SMED because the because of automation and the rate of production has gone up so much. Now we wish to be able to change the molds within matter of minutes rather than hours. And the contemporary technology allows us a literal single minute exchange of mold. Okay. But for that to happen, you have to have some standardization in all the molds for different parts in terms of loading, unloading, in terms of connections which come and go through the mold, like all the pipings and electrical connections. Nowadays, molds have a lot of electronics. So all those electrical connections, hydraulic connections, pneumatic connections, whatever. Okay. So all the molds have to have some standardization. It has to be compatible with the automation for loading and unloading of the part. And the whole thing goes integrated with the equipment and automation. So mold cannot be separated, as I was saying earlier. The full ecosystem has to be married. So you have to consider the mold design together with the requirements of automation, together with the requirement of single minute exchange of mold, and also automatic quick connection, coupling and decoupling of all the connectors as you load. Okay. And normally, of course, they are mounted and clamped magnetically in order to save time. So the philosophy of mold making is having a sea change. If you want to have the SMED requirement, automation requirement superimposed on the mold function per se. Okay.
Yes.
Okay. Fine.
Okay.
Now, coming back to the maintenance part, uh, do you think that the preventive maintenance requirement on molds is increasing or it is diminishing because of technology? Now, what is your take on that?
No, sir, it's preventive maintenance is maintenance where the wear and tear is happening in the molds. It is not about only the technologies. When the technologies goes also, in India, not that much technology started coming. Still, we are in a older technology. Only we are not using any servo motors for the movement of vegetable. In some of the other countries, they are using it. Even the angular cams and all using. Still, we are using linear cams only. So it is reducing it. It's how we are making it, how we are maintaining it. If you ask us, we don't have any major breakdowns. Still, life would so many of years, not even a single minute. Because of us, there is no line stoppages or customer. We maintain, as based on our experience, maybe somebody will feel we maintain only the lean stock of 4 hours. 4 hours only the stock. The sum of the assembled parts we maintain only 30 minutes. Our cycle time is only 30 minutes. The part assembly parts, every 30 minutes the dispatch will happen. There is no like a stock holding it for 3 days or 4 days. In this condition, as a we never faced any breakdowns or anything. Yeah, where the preventive maintenance and the technologies, everything is plays a role. But our in India till the technology is not that much in the molding.
Talking of mold maintenance, now I move my question to Dasarathi sir. Dasarathi sir, uh, Industry 4 claims that you can do predictive maintenance and condition based maintenance of tooling and equipment. Now, what is your take on that? What is the scope of doing Industry 4 kind of things on molds and, of course, molding equipment so that we are able to make the maintenance part much more predictive? And if possible, we are able to have a bigger mean time between failure and mean time to repair as well.
uh, Predictive or condition based maintenance depends on, continuously monitoring the condition of whatever equipment, whether it's a mold or whether it's the machine. This would be more applicable today in machines because molds still, in terms of plastic molds at least, the life is long, uh, and there aren't too many sensors that you can put actually in the mold itself to. Am I audible? Okay. But on the machine, there's you can have, yeah, oh, much better. So on the machine, you can have a whole lot of sensors measuring pressures, temperatures, and vibrations and so on, and continuously monitor what's happening at various critical areas of the machine. Like for example, you've got uh, Mics don't like me. Huh? Okay, so you can monitor a lot of critical points on the machine and continuously, automatically, and the system itself, like you have hardware, you have software, you have sensors on the machine, can continuously monitor and alert you in case something's going wrong. That is, so if something goes, let's say you got a pressure or a temperature range beyond which this one also will start hating me. Let's see. Okay, so uh, there's a continuous monitoring and alerting if something's going wrong in any critical area of the machine. That would be your condition monitoring. And predictive maintenance is if in the past you've seen that there is a certain pattern of behavior of a particular parameter. If that behavior is in a certain way, you are likely to see a failure and you need to change the part or do your maintenance or whatever. That would be your predictive maintenance. Predictive maintenance, of course, still is, I would say it's still science fiction because you can predict, you can develop software and hardware to do your monitoring and prediction, but you need advanced data, you need historical data for predictive maintenance, which we don't typically have. Historical data in in a very fine granular manner over maybe months or years, and two or three incidences of failures which you've seen, the you've measured the parameters, you've seen the failure happening, and based on that you can say, okay, this is what is going to happen in future. So, but both these predictive as well as condition based are very, very applicable in the mold making industry, both in terms of the machine itself and the mold, both.
Dasarathi sir, would you be able to cite some case study where you have done some similar solutions? May not be for mold, but something similar context.
I can, so maintenance is one thing, but where you really see dramatic and sometimes very funny results are in the productivity and quality improvement. Uh, the one case that we had recently on an injection molding machine, we put in our machine monitoring system, and on the third day, literally the third day after installing the system, the OE went up by 26%. It's astronomical. OE essentially is a measure of your capacity utilization straight away. 26% OE increase is 26% more parts coming out of the machine, more good parts coming out of the machine, which is, I mean, which normally would never happen. But in this case, what happened was that, on day one itself, uh, you get, so our system gives a lot of, reports on the mobile phone, it gives you alerts, and on your laptop, you can see what is happening on the machine, what are your downtimes, what are the causes of the downtimes. So the shop head just saw that, whenever there's a shift change and whenever there's a lunch break, there was a very long downtime. This machine was a very expensive machine, like a lot of injection molding machines tend to be. What was happening? And then they went to the shop next to the machine, to the location of the problem, what they call the Gemba in Lean. They go to the machine and then they find that whenever there's a shift change, there is a small, maybe not a small, it's big actually, a 20-minute, typically a 15 to 20-minute downtime. The shift one operator has gone, maybe 5 or 10 minutes earlier. Shift two operator is taking 5 or 10 minutes later to come. So there's a 20-minute downtime in at every shift change. Secondly, the machine is left unattended, not working. It is stopped during lunch breaks, which is about half an hour. So in an injection molding machine, if you do this, you need to come and restart. The machine, again, warm up the machine, clean the barrel. There's a whole process, right? Because your plastic is actually solidified in the barrel. So you clean the whole barrel out. So after every such, gap in the functioning of in the running of the machine, There's another gap of about 15, 20 minutes to warm up and clean and so on. So in the, this is what, they just stopped this. They said, okay, we are going to have standby operators for this. Why do you want to stop during the lunchtime? And why, and overlapping shifts. What is the business of, operator one going away 10 minutes earlier and then operator two coming 10 minutes later? It's seriously stupid because the machine is so expensive. So they simply ensured that the machine was running 24 hours. That's all. It's a simple solution. But, getting to the problem, getting the data that indicated the problem was, nobody actually knew it because you're not sitting there. Shop head is not sitting, or shop managers are not sitting in the shop 24 hours. That is why the Industry 4.0 system actually is able to give them data remotely. You're sleeping at home and you still, the data is being collected. Next morning you say, oh, this is what happened? Okay, let me go see why this happened. So that was, and the system cost about, about 5,000 rupees a month. Their benefit from this was 80,000 rupees per month. It's like, what is that? 160 times ROI. That's the kind of ROI that Industry 4.0 can give.
Thanks, Dasati sir. Now, my next question is about maintenance of mold. There are some new technologies which are there. They are, of course, sunrise technology. In India, we don't see much of them, but in European world, they are there. In this exhibition, you see a lot of them, by the way. Now, one of those technology is laser metal deposition or laser cladding. You can see in some of those stalls, the videos are being shown. Physically, you can see cladding being done. Now, which means that the worn out surface of dyes and molds could be rebuilt by throwing powder and fusing the powder with laser on the fly with a robot. So that way, it gives a very interesting possibility of extending the life of the mold without having to remake the mold completely. You can rebuild only the worn out surface, remachine it, and it is ready for use again. Now, what do you think is the potential for this technology? Is it already there, according to you, what you know, or what do you think about this technology? Is
Yes,
it a fad, or is it really something
it
that's going
is
to help?
okay. For frankly telling, it's like as of now, where the metal 3D printing is similar to that one, where we can exactly make it. The smaller parts can be make it, bigger parts, but it's like too expensive. As a industry, what we feel, no, it's like too much of expense. Even though finally the cost to be borne by customer, or finally the suppliers has to be borne, it means it is too much of expensive. So it's viable, definitely it is good. Again, it will reduce the lead time. Instead of manufacturing, no, at least many portion by portion, just we can do it and we can correct as a bit by bit, not like one day we'll do it, all those things. This is good, but so much of technology is still not available in India. When the bigger parts itself can't up to 3D printing. That's now in India. But local area, we want to do it. Yeah, it is really good. The laser cladding is a good technology. We can use it, but it's not exactly is in India. We need to explore it.
These technology, ladies and gentlemen, the cost is a major daunting factor as of now. But then cost depends on the scaling. If many people start buying these technology, the cost is going to come down. So now it's a egg and chicken situation. What happens first? First, we start embracing the technology and bring its cost down, or we wait the cost to come down somehow. But that somehow is not going to happen on its own. So the innovators and industry leaders have to start investing in their future. They have to start having faith in technology. And if they take some early steps, and that would result into the technology and options becoming affordable, viable, and widespread. Something similar like what has happened with mobile technology, right? So it's a question of scaling. India is such a big market that scaling plays an immense role in economics of the whole thing. only one person has to switch the mic on, I guess. It's echoing. Hello. Is it working? Okay, fine. Now I come back to Dasathi sir. Industry 4 is also expected to bring in lot of quality improvement through manufacturing process monitoring. One is the, of course, the condition monitoring for doing the preventive maintenance, predictive maintenance, etc. The other aspect of Industry 4 is to do the process monitoring, inline process monitoring, so that any abnormal condition could be flagged immediately and we don't mass produce defects. Now, what do you think about the technologies like, for example, thermography? When a molding is being done, you hear the sound, you feel the vibrations, you visualize the temperature pattern, and based on that, you have a signature for OK parts. You build a lot of data, then you apply AIML. You have the envelope, the tolerance envelope, that okay, if the variation is within this band, it is okay. If it is shooting out of it, you raise a flag that something is wrong. Now, what do you see the potential of that kind of Industry 4 deployment?
They still hate. The mic still hate me. Okay. Yeah, there's for quality. Uh, for quality, both in terms of one inspection after you've produced a part, as well as ensuring that the quality is correct by ensuring that the process parameters are correct. In both these areas, Industry 4 is already playing a very big role. I'll give you an example. So one of the places where we have our system installed, you have a robot plucking out the part from the machine and then displaying it to a CCD inspection camera. And that camera tells the robot whether the part is accepted or rejected. It's a visual inspection. So inspection can be visual or, once you've done it, it's primarily visual. But before doing it also, you can do that. So the robot shows the part there. And then if the part is rejected, we get a signal. One, the robot knows that the part is rejected, puts it in the rejected bin. If it's accepted, it puts it in the accepted bin. And we get a signal. Our software and hardware get a signal from the inspection camera on whether the part is rejected or accepted. And based on that, we count the parts, and then that is used for tracking your rejections and then calculating OEE and so on, whatever. This is post-production inspection. And the second type is there's a part which, after the part is made, it's put on a weighing machine. And from the weighing machine, we are directly reading the weight of the part. If that weight is beyond a certain band, either it's too much or too less, for whatever reason, we take it as a rejected part. And then we send an alert to the operator to put the part out through a lamp and so on, to put it in the rejected bin. This is post-production, but before production, if you want to ensure that your parts are coming out correctly, your process parameters have to be correct, like your temperature and so on. Now, if the injection temperature is too high, beyond whatever 200 to 300 degrees is typically our injection temperature, but if it's too high for a particular material, then the material is going to decompose in certain ways. I mean, you're changing the characteristics that you want in the final part. So the temperature can't go higher than that. And if it's too low also, you're going to have problems injecting, and your mold is not going to get filled. You're going to have various problems like visual flow lines or empty pockets and things like that. So, or the torque on your screw, that is going to become very high. So your temperature has to be correct. And Industry 4 system will it's got sensors at various points on your screw and probably next to the mold itself. And then we can keep seeing if the temperature is correct. If the temperature is not okay, I mean, this can be even a, like if I'm the operator, for a particular part, I've been asked to set a temperature, particular temperature on the control system of the machine. I set it wrongly. Then you get a whole batch, whole shift of rejected parts. It can be as simple as that. So the system can immediately give you on, our system will give you on the mobile phones of concerned people, it says temperature is wrong on this machine or this particular part and so on. So it can be both these. Check and ensure that the process itself is correct. To check individual parts and see if they are okay or not okay. Both these.
Thank you, sir. So whenever we talk of quality, mostly we are referring to mass production scenario. And mass production scenario is good and mass production scenario is bad. It is good in the sense that you can apply SQC, statistical quality control, sigma level, and all those control charts, etc. All the techniques which are cut and dried and proven in the industry long back. But statistical techniques have a flip side also, because anything which is statistical requires lot of rejections to happen before you are able to identify the root cause. Now, I am reminded of in childhood, we used to get novels on railway stations, those cheap crime novels, detective novels, etc. Okay, Colonel Ranjit and all those on wheeler stalls. Now, one feature of those novels was that every third page there used to be a murder. And the detective was able to catch the culprit after minimum 20 murders. Now, do we like that situation, or we like Agatha Christie, where with just one murder she is able to catch the culprit? Okay. So, obviously, if we go into engineering basics rather than going to statistics, probably we can reduce the number of casualties. Right. Now, with that idea, I leave the audience that please think about it, how to have more engineering basics in our industry 4, in our monitoring system, so that we have fewer casualties and we don't go down the same way as our predecessors have gone, having the quality issues. Okay, fine. Now, Dasrathi sir, a lot hoopla has been there for industry 4. Do you perceive that it is affordable in India?
It's not only very affordable, India can't do without it. India is known as a nation of low productivity. You'll read a lot of statistics about India's labor productivity typically is 1/5 of the uh, productivity in the US, for example. And that's really bad. And a lot of business that should be coming to us because of this is probably not coming to us. And we are only dependent on low wage rates as of today. Wage rates are low, productivity is poor, so they're kind of balancing each other. But there'll be a day when wage rates become high enough that, and the productivity is still low, then what do? People are simply going to move away from us. Already we're getting, competition from Vietnam or Thailand or Turkey, South Africa, Brazil, lots of very competitive countries where productivity is higher, wage rates are probably comparable or even slightly higher. We need to absolutely improve. Uh, in discrete manufacturing today, OE is as low as 40%. And the machine downtime can be as high as 50%, which is pathetic. Pathetic. We don't do anything about it because we're still surviving because of our low wage rates. So it's inevitable.
Thank you, sir. Finally, I want to ask both the speakers about what is their vision and what do they expect in near future from Indian market and Indian mold making industry to happen. It could be a wish, of course, but what do you wish should be the supporting factor? Like if we require any policy support from government that is gonna help. So could you articulate your vision and your thought on that?
Yeah. You go. It's okay. Thank you, sir. Actually, it's not about this is support. Already, this government is doing for the thing. Again, okay, the earlier this thing it's already talk about the vision or what the policies, all those things. But now till the policies again, no, it's about how we are reduce our lead time, like technology and all those things. How the tool makers reduce the lead time. How the same tool just we do it in other countries. The bumper tool just they're making it a more than 40, less than 45 days. But we in India, we need a, nearly 28 to 30 weeks just to make it. For us, the problem is the steel. Getting a steel itself will take 4 to 6 weeks. Again, designing we take where the other countries they do the design within 3 days. We need a 3 weeks to design. That's okay. This is about our again here about the skill of a man. Even though whatever the technologies keep on goes us, we need to increase on our manpower skills where the skills plays the major role to reduce the lead times and all those things. When we are in the production, we need the maintenance. There, the technology will not come to the retrieval of mold or anything. There, the human skills needed, where they need to weld the match and all those things. This cannot go down. Where we have the lesser lead time to lesser lean system to produce the parts, where we have less than 4 hours or 2 hours. Most of the thing now OEMs working on a lean system only. One day, more 4 times same mold load and unload. So in this condition, the only the lean, however the man skill is much needed than your technology. Technology is also needed on the equipment point of view to retrieve all these things. Again, what Sir told the cost. Again, for the affordable. If it has come affordable, the peoples are again whatever was like going the I need less cost parts, but we need the affordable technologies are at higher costs. So we the government work on again over the providers, users, all together to work on this how to use the technologies to reduce it. Thank you.
Yep. Two things: skilling, do things right. How do you do things at all, and how do you do things right and faster? That skilling, knowledge. So all your everything from making the tools to making machines to using the tools, using the machines, the operator level, all these skilling and knowledge, there only the government can, step in and then improve it at the policy making level. Like countries like Taiwan and South Korea and so on. Initially, that tooling was extremely, extremely strong and fast. I remember there were days, I don't know, 2, 3 decades ago, when we used to come up with, make a tool in 6 months, it used to come in 2 weeks from other countries. So we need to, speed up that. So skilling is one very big thing. Two is productivity improvement. As a policy across the nation, it's across industries, but molding also. There's so much waste. Like I said, I mean, we're a nation that is very happy with 50% machine downtime on an average in shop floors, in discrete manufacturing shop floors, which is, so in mass production, it's much, much better, but it still can be improved. But in discrete manufacturing, it's really pathetic. And we really need to do, as a nation, we need to, completely focus on this. Industry 4.0 is one of the ways, and get a culture of reducing waste. Waste as in kachara. I'm not. It's not. So we need to reduce that waste.
Well, finally, some loud thoughts from me on various points. One point that I want to touch upon here is the notion that plastics are harmful for environment. Well, it's a wrong notion. Plastics are hydrocarbons. They are organic. There are no poisonous material in plastics. Only thing is, diamonds may or may not be forever, but plastics are forever. So they don't biodegrade. They are there. But then it is up to us to make a good use of those plastic waste. Like you can always fill it in the wall, inside the bricks, make the bricks hollow, fill the waste plastic inside, It will give thermal insulation, it will give sound insulation, and let it be there forever. Okay, so we have to find the right use. Also, there are plastics which are recyclable and which are biodegradable nowadays. So the movement should be in that direction. That how to do a 360-degree economy in plastic, how to segregate and collect the plastic waste, how to reuse, recycle the plastic waste. So that stigma that plastic has got has to be wiped off. That is point number one. Point number two is in India, uh, what IT has done to all other technologies, core technologies of engineering, is something comparable with what cricket has done to all other sports. Now that picture has to be corrected because we need a balance of competency in various engineering domains. So my advice to youngsters is please don't shy away from the core engineering branches. The country will need core competence in core engineering branches as well. And it's a matter of time before the returns which it will fetch in terms of career growth, etc., will even out, right? So some effort is required in correcting that aberration. Okay, IT everybody should know computer, everybody should know how to drive, but everybody should not become a driver. There are other professions also required in the country, right? So I leave you with that thought process. That is second point. Third point, as India, if we see our traits, we are very good at making a house, but we are very poor at making bricks. So we are good at screwdriver technology, we are good at system integration, but on material side, we are rather poor. On component side, we are rather poor. Okay, and that is a correction which needs to happen. That we have to balance out. In the spirit of Atmanirbhar India, we have to balance out our weakness in material side and in component side as well. And of course, in electronics, semiconductors, which is already, of course, on the radar, government's radar, and a lot of efforts are going on in that direction. We hope that it will fructify soon. Okay. And the last part that I want to address is a question from the previous session, which Rajesh Nath sir had asked, that localization versus globalization. Is the world moving from globalization back to localization with Atmanirbhar India and such movements in all the countries, including US and Europe? Well, as I said, as Indians, we are very good at system integration and building a house. Now, according to me, for a stable equilibrium to happen in the world, you can't expect to export unless you import something. Okay, so we can't ever hope to do the full process in house. We can't be fully backward integrated. We have to be open because we want to export. We cannot be out of the world. We have to deal with the rest of the world. So each country shall do what it does the best. If Belgian glass is best in the world, let them make glass. But we do something which is fetching us premium, which is our core competence, where we are best as a country. So we have to select those areas and we have to do more and more work in those areas which will fetch us premium. Ultimately, it is a question of balancing the premium. Okay, high premium fetching jobs we have to retain. Other things one can outsource, right? So I hope I have given a logical engineering answer to the previous session's open question. With that, we throw the session open for question answer from audience.
Uh, Hello, my name is Rajgopal. I'm from Quad Tooling. Am I audible? Yeah, I'm from Quad Tooling Technologies, and we have a stall here. It was a very insightful session. I don't have any specific question, but I thought maybe I will take this opportunity to share some of my own thoughts on various very pertinent questions that Mr. Avinash Kare has put up to the forum. Well, I think my thought about the point that you raised regarding the contemporary developments in molds and tools or whatever is the fact that it has been a very traditional technology for many years. I completed my PG 20 to 30 years back and probably we are doing the same things that we did long time back, the same core cavity and all that. Even then we had P20. There is some small material improvements which has happened now. But I think over the years, what I see is there is no change in the technology. The same textbooks that we used to refer long back, they're all fundamentally relevant even today. But today, the focus is more on probably the productivity improvements, the kind of prismatic structures we had earlier to what we have, curvaceous surfaces, designs, all have changed now because of the advancements in CNC technology and all that. You can give shape to whatever you visualize today, and that has been the key thing in going ahead as far as product development is concerned. On the aspects of productivity, the latest technologies like CAD CAM has come. The last decade has always been every tool room, even the small tool rooms have started using CAD CAM technologies to manufacture. That has also become sort of commonplace now. So going ahead, probably more of CAE technologies will be have to be used, so that not just depending on the experience of the mold maker or the tool maker, the CAE technology, engineering and analysis technology is used to foresee the possible potential failures that we might have after the product is made. So that's one area I think still a lot of work needs to be done. That is the progress that we are looking at, and those software has to become more commonplace and accessible to the common tool rooms. India, all said and done, we don't have any huge tool rooms in India. Talking about molds, the moment you cross making molds about 10-20 crores in India, you become the cost of the capital, which is another point which I wanted to share here, is the cost of capital is so high here that the individual technocrats will become burdened with all these credit issues. So we are not able to access the CAE technologies. That is where probably the governments will have to come forward, set up engineering centers more, and be able to offer CAE technologies to the common mold makers and all that. Now coming to the OEE, a lot of discussion happened. Parthasarathy sir has given good exposure to OEE. I feel that is the thing going ahead. I also share his thoughts that doing it around even at 40%, he's on very much higher on the radar. There are companies doing at 15%, 10% OEE without realizing that the OEE is so low, and it is taken for granted. And with that low OEE, we are still looking at adding one more machine. So which is just criminal, that the return of the investment is so low in India. It has to be a factor, and I'm very glad that I would like to personally meet Mr. Parthasarathy sir to understand what exactly he is doing in order to improve the OE in these common areas. There's a huge potential there, and it is an absolute need of the hour. The biggest obstacle that companies have is data collection. If you have data, we can analyze the data and take corrective actions. But the problem is in collecting accurate data. Although you have people, manually to collect the data are more or less most of the times inaccurate, and all the decisions that you take based on those data is all not really yielding results. So that technology is what is very exciting, that you can install some systems on the machine, and I understand from him that we can collect the data, which is very interesting. And one more point which I thought is very, very important now, adding to Mr. Nandakumar's view, is the fact that today the most important thing is that we need to understand the product. A mold maker has to understand the product clearly, the engineering requirements of the product before even getting into the design of the mold. I have seen many cases where we develop the mold, we develop the part, and then we find that the parts are not good. Engineering point of view, it is not a good, a mature product in order to give the required output. For example, we see that in a Toyota car, the engineering is so good, the feel is so good in a Toyota car. Tata is catching up there now, but generally Tata is not of the same engineering level as Toyota cars that we see. So probably engineering aspect has to come into the mold making. That's very, very important, where we analyze the dimensions and understand the product requirements. These are, I thought, some of the few things And from government's point of view, it's very important for us to understand that the whole political situation, the geopolitical situations which is developing all over the world, India is going to be the next hub for all the electronic component manufacturing. There the government has done a long way to go. And as entrepreneurs, as industry technocrats, technical people, we need to be focused, and we just focused on only quality. Quality is the thing that really keeps us floating. Only way to thrive is only by following quality. And that consciousness, quality consciousness, is not just about dimensions, but it is all about the entire gamut of quality is to be focused on. Very important, sir, because the future is, already there is a development happening that all the laptop, you cannot import any of these parts from to India. You have to develop it. There are many companies like Intel and other companies which are looking at Indian ecosystem for developing all these electronic and parts, which is not available in India. They are finding it extremely difficult to produce these kind of quality components. It's no big deal. It is possible. We have it within us, but then there are certain things that the government has to take care. And as entrepreneurs, we need to take care to ensure that we reach that level to have a good ecosystem in India. Thank you.
Thank you, sir. Now, based on what you said, I would like to register 2-3 points further. One thing is that the design departments in die and mold, somehow for historical reasons, I don't know why, they used to have fortification around them, and they did not allow people from other competencies, other domains to enter anywhere near that domain. Now, because of that, what has happened in die and mold, the designers are all traditionally mechanical engineers who have read those same old textbooks. But it's time that we need people with hydraulic competence, people with electronics, people with IT background into the design departments for die and mold. Because that is what would give us a technology edge, and we'll be able to catch up where we are lagging in terms of having electronics in our die and molds and automation in our die and mold. So that is one requirement. Second is our companies and our corporates are considering capex, and not as investment, they consider it as a muda. And the same ditto applies to capability development and training for competency development. It's time that our corporates start treating it as an investment rather than as a muda. It's not a loss, it's an investment for the future. Okay. So I think with these few words, we can end the session. Thanks a lot for patient listening and good question answer. Okay. I hope the session is useful for you, and we are always there, of course. We can always interact outside. Thanks a lot. Thank you.
Ladies and
I thank my co-speakers, and thanks to all of you, and thanks to Message Stuttgart for giving us opportunity to present our views in front of you. Thank you.
check. Ladies and gentlemen, as we conclude the first half of the Moldex India conference, let's express our gratitude to our distinguished speakers. A heartfelt thank you to our esteemed panelists, Mr. Avinash Khare, Mr. Gireesha, and Mr. Nandakumar, for sharing your profound insights in that enlightening session. Your expertise has truly enriched our understanding of the advances in the tooling, molding, and maintenance sector. Now I invite Mr. Mukesh Kharia, Division Director of Message Stuttgart India, to the stage to felicitate our distinguished panel of speakers. A heartfelt thank you to Mr. Parthasarathy for shedding light on crucial nuances of the topic. I would like to extend a note of gratitude to Mr. Nandakumar for sharing his insightful perspective. I would like to mention that Mr. Avinash Khare will be rejoining us for another engaging and insightful session in the second half. So, Mr. Khare, your felicitation is yet to come, and we eagerly anticipate your continued contribution.